Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through what was covered in week 4. So we started our journey through continuous probability distributions. So we're still looking at random variables. We looked at them last semester as well. So a variable is something whose value changes. A variable is random if the value it takes is determined by chance. So this semester we're looking at continuous random variables. These are random variables that can take any value within a range. So just some notation here. This says x is between but not including a and b. This says x is between and including a and b. So round brackets means it doesn't include that value, and square brackets means it does include that value. So these two say essentially the same thing when we're talking about continuous probability distributions because of this fact here. So when x is a continuous random variable, the probability it takes any one value is 0. That probably makes absolutely no sense, so let's look at an example. So let's say I pick a student at random from our class and let x be their height in centimeters. So x is a random variable. The value it takes depends on who was picked, which is due to chance. So x is a continuous random variable. So the height of the student I pick, it's going to be between, say, 160 and 200 centimeters, right? But it can really be any value within that range. It's possible someone would have a height of 172 centimeters or 172.315 centimeters or 172.9865139 centimeters. You get the idea. The height doesn't have to be a whole number. So what does this fact here mean? Well, it means the probability x takes any specific value is 0. So if I pick someone at random and measure their height's not going to be exactly 172 centimeters or exactly 172.5 centimeters. It's just so unlikely that that would happen because there is an infinite number of possibilities for that person's height. There's an infinite number of possibilities between 160 and 200 centimeters. And that's why the probability x takes any particular value is 0. It's like 1 over infinity. 1 over a really, really large number gives you something really, really close to 0. So when we talk about continuous random variables, we're interested in two functions. Firstly, the PDF or probability density function. It allows us to calculate the probability x is within a range of values. So let's go back to this example of the height of a student in the class. The probability the height of that student is exactly 170 centimeters, well, that's 0. But what I can calculate, what won't be 0, is the probability that their height is between two values, like between 170 and 175 centimeters. So how do we calculate this probability? Well, to calculate the probability that it's between like 170 and 175 centimeters, what we do is we take the integral of the PDF, which is this function here, between the two values that we're interested in. So the probability x would be between 170 and 175. I'd integrate the probability density function between 170 and 175. So there are certain rules that are placed on this probability density function for it to be valid. So these are the two conditions that you need to know. Firstly, the PDF, the function, must never take negative values. And that's true for any value of x within the range of acceptable values. So if I substitute any x within my range of acceptable values into the probability density function, I can't get a negative number. I can actually get a number greater than 1 because this one doesn't tell you the probability. It's just a function that we integrate to find the probability. So the second condition here says that when you integrate the probability density function over the range of acceptable values of x, you always get 1. The area under the curve is 1. So let's look at an example to show what we mean. So here's the situation. We have this function here, px. I want it to be a valid PDF. Now it satisfies the first condition on the previous slide. This will only ever take positive values because the bottom can only be positive any square number is going to be positive. So positive divide positive is always a positive. The problem with this function is it doesn't actually satisfy the second condition. So why is that? Well, the second condition says when I integrate a function that's a PDF, it should equal 1. So we're going to integrate over all possible values of x. So x is greater than 1. That means x is between 1 and infinity. So just to make this a little easier to work with, I'm going to rewrite it as x plus 1 to the power of negative 2. So we've integrated functions like this heaps of times. What we do is we increase the power by 1 and divide by the new power. So I'm just going to make this a little easier on myself. Remember, I can move negative powers to the bottom and replace with positive powers. This is actually the same as negative 1 on x plus 1. So let's substitute in 1 and infinity. So if I substitute infinity, think of it as me substituting a really, really, really large number. If you substitute a really, really, really large number here, you get something close to 0. Negative 1 divided by a really, really large number is very close to 0. If I substitute 1 into this formula, I get negative 1 on 2. So it turns out that this integral, when I integrate this function, I actually get positive a half. That's why the second condition on the previous slide is not satisfied. If this is a valid PDF, when I integrate it, I should get 1, not a half. So how can I fix this and make it a valid PDF? Well, since the integral is a half, all I need to do is times it by 2. If I times the function by 2, everything here will be multiplied by 2, and the area under the curve will be 1. So if I change this to a 2, it is a valid PDF as it will satisfy both conditions on the previous slide. So now what I'm going to do is use this new function to calculate this probability here. So now I'm going to calculate the probability x is between 2 and 4. Remember, the probability x equals a certain value is 0. But we can find the probability x is between two numbers like 2 and 4. Note it really doesn't matter whether we include this value 2 or not, because as I said, the probability x equals 2 is 0 anyway. So to find the probability x is between 2 and 4, all I do is integrate the probability density function between those two values, 2 and 4. So this is very similar to what we just did. So remember, we figured out that the integral of 2 over x plus 1 squared, it'll be negative 2 over x plus 1, and I'll evaluate between 2 and 4. So when x equals 4, I get minus 2 over 5. When x equals 2, I get negative 2 over 3. And so I end up with 4 over 15. Whenever you're asked for a probability, you should get an answer between 0 and 1, which I did. All right, let's now turn our attention to Cdfs. So we've already looked at PDFs. Now we're going to look at Cdfs, the cumulative density function. It's very closely related to a PDF. So what the Cdf allows you to do is calculate the probability that x is up to and including a certain value. So what we're doing here is we're integrating the PDF from the lowest possible value x can take up to x. Probably makes no sense. So let's look at an example. So this was our PDF in the previous example. Remember, we had to change it to 2, so the area under the curve was 1. So if I want to find the CDF of this random variable x, what I do is integrate the PDF. Once again, we're integrating. So now we have to think, what would be the limits of integration here, the two numbers that go here and here? Well, what goes here is the lower limit of x. Remember, we said that x has to be greater than 1. Remember, it doesn't matter whether x is greater than 1 or greater than or equal to 1, because the probability x equals 1 is 0. So this is the lower limit, and I integrate up to x. So Remember, the integral of this, as we saw before, that's going to be -2 on x plus 1. We're going to integrate it between 1 and x. So, how do I substitute x into this? Well, I actually just leave it alone. If x is substituted for x, I just get the same thing. This will just be -2 over x plus 1. But if I substitute x for 1, I get -2 divided by 2. And of course, this thing here just becomes +1. Turns out the CDF is just 1 minus 2 over x plus 1. So what have I actually found? I found a function that will help us calculate the probability that x is up to and including a certain value. So for example, if I want to find the probability that x is up to and including 5, remember x has to be more than 1, but the probability it's up to and including 5, I can simply substitute 5 into this formula here. It will simply be 1 minus 2 over 5 plus 1, which actually gives me 2/3. So CDFs can be very helpful and make calculations simpler. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.